Okay, hello again. We can have a look at the Doppler effect. Now, if you've been watching a few of these videos, you'll be used to my very bad drawings, but they do demonstrate the point, kind of. So, Doppler effect. I like to use the example of sound. If you've got a fire engine that's moving in this direction, okay, what's happening to that sound? Well, coming out the front in the direction that it's moving, we find that the sound waves are squashed together. Okay, now you should know the definition for frequency, which is the amount of waves that pass a point in 1 second. So if you've got lots of waves squashed together, you've got a higher frequency. Okay, the other side, we've got the opposite effect. So those waves are becoming more spread apart. And same applies. So if you've got less waves, you've got a lower frequency. Okay, and this is why if a fire engine comes past us, we hear a higher pitched sound because of the higher frequency. As it goes past, we hear a lower frequency, a lower pitched sound. Okay, now this can be applied usually in exam questions. It's quite often with sound, or, and the one we're going to have a look at in a second, is to do with microwaves. Okay, now if you get a question where you've got something being reflected back and it's talking about the frequency, it's talking about the wavelength, the chances are it's going to be the Doppler effect. So the first question, what is the name given to the effect used to determine the speed of a cricket ball? It is Doppler effect. Okay. Compare the wavelength, frequency and speed of the reflected microwaves. So what we've got here is a microwave, and I'll draw the gun again, not the best of drawings. But if we've got our cricket ball, it fires a microwave and it's reflected back to be detected. Okay, now we know microwaves are part of the electromagnetic spectrum. Okay, so their speed is not going to change. It's the same as all the other things on the electromagnetic spectrum. So it's 3 times 10 to the 8 meters per second. So in this question where it says compare wavelength, frequency and speed, well, speed is going to be the same. Okay, so speed before is equal to the speed afterwards. Because we're talking about microwaves, they're not changing. Secondly, if you think about this, if it's been squashed, so when it's coming back and that ball is moving in this direction, it's kind of pushing the waves back together, it's increasing the frequency. So the frequency is going to increase. Now, if you think back to the video where we were looking at the electromagnetic spectrum, if you've got a higher frequency, what happens to the wavelength? Any ideas? Okay, wavelength would be decreased. Okay, because if we've got more waves per second, the wavelength, which if I draw a larger one, the wavelength is peak to peak, or trough to trough, or across there. Okay, now if we've got more waves, we can see that that wavelength is going to decrease, so the wavelength decreases. Okay, thank you.